everyone, in today's lesson from Chapter 6, we'll take a look at inequalities in one triangle. If you take a look at the first triangle that I've drawn, triangle ABC, with two sides congruent, we know from this diagram that angle B must be congruent to angle C. And that's because this triangle is isosceles, and because of the isosceles triangle theorem, which says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. But if you take a look at the second figure on the right, triangle RST, notice in this case that side RT is 13 and side RS is 12. And that means that this triangle is definitely not isosceles. So from this diagram, we know for sure that angle S and angle T are not congruent to each other, but do we know if the measure of angle S is greater than or less than the measure of angle T? And that's what we're about to discover in this section. So our first theorem says if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. Okay, so if we're given a triangle, say triangle RST again, this time it looks a little different. And if we know for sure in this given triangle, so let's say given triangle RST, then we know for sure that the side length RT is greater than the side length of RS, which you can see I've drawn it to be that way. Then we can say for sure that the measure of angle S is definitely greater than the measure of angle T. So, for instance, if this side length RT were 15 and this side length RS were, say, 8, then according to this theorem, since this side is longer than side RS, then the angle opposite the first side, the longer side, would have to be greater than the angle opposite the second side. So therefore, the measure of angle S is greater than the measure of angle T. All right, let's take a look at another example of this. It says, name the largest angle and smallest angle of the triangle. So first, in these problems, you may have to do a little bit of work to find some missing information. And what we're missing in this case is the length of the third side, which we can find because it's a right triangle. And it's actually a multiple of a 3, 4, 5 right triangle. So this hypotenuse has to be 10. The hypotenuse is always going to be the longest side in a triangle. So since that's the longest side, our 90-degree angle has to be our largest angle. So 90 degrees, or angle I, has got to be our largest angle. Okay. Now, to name the smallest angle is going to be opposite the shortest side. The shortest side in this particular drawing is the side length HI with 6 as its length. So the angle opposite HI would be angle J. So therefore angle J would be the smallest angle in this triangle. So the bigger the angle, the longer the side opposite it. The smaller the angle, the smaller the side opposite it. In our second theorem, it says if one angle of a triangle is larger than a second angle, then the side opposite the first angle is longer than the side opposite the second angle. So this is just the converse of our first theorem. So in our first example, to illustrate the theorem, it says we're given triangle RST, where the measure of angle S, this angle, is definitely greater than the measure of angle T, this little angle over here. Therefore, we can say that side length RT, the length of RT, so I'm leaving the segment off of the segment symbol off of it, the length of RT must be greater than the length of RS, because RT is the side opposite angle S, and RS is the side opposite angle T. So again, the longer side is going to be opposite the larger angle, smaller side or shorter side opposite the smaller angle. Let's take a look at another concrete example. So let's take that triangle RST and let's put in some numbers. and understand that we're only working in one triangle right now. So if we had angle measures of 105 degrees and 46 degrees, and we're asked to name the longest side and the shortest side of the triangle, the first thing that you would want to do is come in and find that missing angle. And don't forget, the angles in a triangle, the measures of those angles always add up to 180 degrees, so that leaves us with 29 degrees for the measure of angle T. Okay, so if we want to name the longest side, we have to look for the largest angle, which is angle S. So the longest side would be RT. If we want to name the shortest side, then we look for the smallest angle, which is angle T, and the side opposite angle T would be RS. Okay, we're going to finish off today's lesson with a series of corollaries. And corollary 1 says the perpendicular segment from a point to a line is the shortest segment from the point to the line. We've talked about this before when we talk about distance from a point to a line. Remember, the quickest way to get from point A to this line is to go along that perpendicular segment. So line segment AB would be shorter than any other segment we could draw. So say if I went in this direction from A to this point D, or from A way out to this point C, we could say for sure that line segment AB is definitely shorter than AD, and line segment AB is definitely shorter than AC. In our second corollary, it says the perpendicular segment from a point to a plane is the shortest segment from the point to a plane. So we're going to draw it so it appears to be three-dimensional. So just draw a parallelogram to represent a plane, and then we have point A, and again we want to talk about the shortest segment. So going from point A to this plane, we want to measure it along the perpendicular. So AB would be the shortest distance from the point to the plane. If we went in any other direction from A to a point in the plane, say out to point C over here, we could say for sure that AB is definitely shorter than AC. And our last theorem for today, it's called the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if we take a look at a triangle, and we have A, B, and C as our vertices, if we take the length of AB plus the length of BC, what this theorem says is it has to be greater than the length of AC. If we take AB plus AC, it would have to be greater than BC. And finally, if we take the length of BC and add it to AC, it would have to be greater than the length of AB. Okay, now you may have tried an experiment in middle school where you took like sticks or even spaghetti and broke it into pieces and tried to see which lengths could make triangles. So we're going to do it just numerically, and through this example right here. It says the lengths of two sides of a triangle are 3 and 5, and we have to find the possible length for the third side, and we're going to get a range of values. So this is our triangle, this little triangle there with the wave in it. So we have sides of 3 and 5, and this third side. So according to our theorem, if we take and add any two sides, so the 3 and the 5, it has to be greater than x, so that gives us one inequality to solve. If we take x plus 5, it has to be greater than 3. And if we take x plus 3, that has to be greater than 5. So if you solve all three of these inequalities, then you'll find your range of values for that third side. There's going to be like a minimum value and a maximum value. So this tells me, the first inequality tells me that 8 is greater than x, or in other words, x has to be smaller than 8. So this third side right here could be 7.99999, and we could create a triangle. And the second inequality, well, when you solve it, you get a little bit of an issue, because when you subtract 5 from 3, you get the statement x is greater than -2. So we're just going to discount this, because we know that x can't be negative, and this inequality tells us that x could be something like -1 or -1.5. Okay, move on to the third inequality. If we solve it, it tells us that x has to be greater than 2. So in order to make a triangle, x could be like 2.1 or 2.01. It just has to be even a little bit bigger than 2. So to answer the question, the length of the third side must be greater than 2 and less than 8. Now, writing the three inequalities and solving them really doesn't take too much time, but you know that I always try to look for any shortcuts that I can give you. Okay, so a shortcut in here would be if you add the two known lengths to find the maximum length of the third side. So you add your two sides, and that gives you the maximum. So think of that as your upper limit. Okay, to find the minimum, you find the positive difference between the two sides, and that gives you the minimum value. So find the positive difference between the two sides to find the minimum value. And again, you guys, this is what's called the triangle inequality theorem. All right, good luck on the homework. As always, send me an email if you have any questions.